Hello everyone, my name is Baturbek. I'm a first year master student in electrical and computer engineering. Today I would like to talk about field programmable logic gate arrays for IoT systems. Here I provided a QR code for this presentation. You can download it and follow with me. In this presentation, first I will briefly define the terms IoT and the field programmable logic gates in the scope of this presentation. Second, I will give some background information and the motivation for this presentation. After that, I will share my literature review results with you, and finally I will conclude with the future perspectives related to this topic. Internet of Things basically can be defined as a giant network with the connected devices. These devices usually use embedded sensors to gather data, which can be used to improve our services and the user experience in different spheres. And field programmable gate arrays is made of interconnected logic blocks, which can be reconfigured. These configurable logic blocks comprised of lookup tables that store Boolean operations. Hence, any sequential and combinational electrical circuits can be modeled using lookup tables. That is why this makes the FPGA powerful too. And besides, depending on the functionality and the desired implementation of FPGAs, they can be reprogrammed. This is a major difference between FPGAs and application-specific integrated circuits, or ASICs. Before moving to our main discussion, I want to have a short discussion and give some background information about the FPGA and the academic research that is going on right now. There are several challenges in IoT systems, such as the security, independence, communication, infrastructure, and the cost. One of the effective solutions can be cloud computing to these problems, and this practice usually utilizes a remote server hosted on the internet and where data is managed, stored, and processed remotely. However, cloud computing can be ineffective for IoT devices or IoT systems with microcontrollers because of their speed performance. Therefore, a major benefit of FPGA-based systems is the parallel and simultaneous execution. Thus, we don't need to create a new communication infrastructure for IoT, as FPGA-based IoT systems would support our daily cellular connections and would operate effectively and more efficiently. There has been a couple of academic research on the application of FPGAs to IoT systems. One of them that I want to mention is the design of FPGA-based intelligent gateway for industrial IoT, which was published in 2019 by Erkan and Ayazawi. And there are difficulties in the process of reliable data collection and integration analysis of production-related data structure and the data industrial technology. In this paper, the authors proposed a modified version of an adaptive neurophysics inference system, or ANFIS algorithm, and they implemented in a Sync FPGA board and as a software and hardware components. Because as we know that FPGA consists of two parts, programmable logic part and software part. And their work is, for me, is like a seem to be embracing work for fourth industrial revolution, and they highlighted that the new digital technologies can transform industry 4.0, and where FPGAs can gather and analyze data across machines, enabling to get faster and more flexible and more efficient outcomes. And their result and their design is highlighting that the power of parallel execution, and FPGAs can handle different type of data sets, and their approach achieves a significant performance and resource utilization rate in industrial IoT systems. As we can see in this picture, cloud computing and sensors, industrial devices, all can benefit from FPGA, the speed of FPGAs, and can be integrated all together. So now moving on to the motivation. According to Cisco, by 2020, nearly 50 billion smart embedded devices will be interacting via the internet. However, this growth brings with the implementation challenges to which solutions need to be found. Therefore, communication among IoT devices needs to shift to machine communication platform while maintaining its flexibility and power efficiency. And one possible solution can be FPGA-based designing for IoT systems. And the aim of this research was to analyze academic papers in this topic and try to find a gap. And then the second aim was to find how much FPGAs are power efficient. And to conduct this systematic literature review, I have used the model which was created by Kitchenman and the Charters for systematic literature review. It involved several activities such as the development of research question protocol, proper identification of primary studies and selection criteria, and extraction of data and the synthesis and reporting the review results. As we can see in these uh, 4 stages, I've tried to include all of them. The analysis of the paper showed that the number of research has been declining since 2016. The graph showed that in 2019 only 2 academic papers were published on the implementation of FPGAs in IoT systems, and according to data that the topic is not getting enough attention from researchers and the engineers. However, it doesn't imply that FPGAs are an effective solution. Hence, we can say that FPGAs still can be integrated with IoT devices. Another result that I found is FPGAs can be 3 to 4 times power effective and up to 30.7 times energy efficient. Therefore, it seems apparent that IoT systems can benefit from FPGA's parallel execution significantly. However, another finding is that from this literature review is security of FPGA-based designing in IoT systems has not been discussed thoroughly, and it seems to me that this is really lacking in academic papers. This is really important because in the Internet of Things industry, in our daily life, a lot of information is being shared between the devices like smart houses, self-driving cars, and other devices. But the information is not protected, as the hackers can hack our system and also steal or change our information. In such circumstances, we need to develop a cryptographic algorithm to protect our data. And therefore, in my future work, I'd like to focus on the cybersecurity of IoT systems, which is based on FPGAs, and the possible solutions that to this problem can be bitstream encryption and PUF technology. And I also want to mention that there is an assumption that FPGA-based systems are harder to attack because of their reprogrammability and parallel execution. However, it seems like wrong. That is why I want to focus on this cybersecurity problem. And PUF technology is a digital fingerprint that is unique to each integrated circuits with an output value that can be that cannot be reverse engineered. That is why I think it seems pretty logical that the PUF technology can also improve FPGA security. And also bitstream encryption feature of Xilinx FPGA also allows user to protect their designs from being copied and from reverse engineered and from attacks also because of a bitstream encryption. And that is why I think the future perspective of these directions need more attention from academics and from researchers. um, and the application of FPGAs can be varied in different spheres. For example, consumer electronics, video image processing, and scientific instruments also can benefit from FPGAs. Parallel execution and simultaneous, because if the speed in FPGAs is compared to microcontrollers are much higher. However, there is a drawback of FPGAs that the power efficiency sometimes might not be as effective as we want. That is why I think we need more research on these areas that focus on the implementation of FPGA-based IoT systems. And to sum up, in this presentation, I've, briefly discussed what is IoT systems, what is field programmable gate arrays, and why it's matter. And the results show that and highlight that there is security of FPGA-based designs needs more attention. And in my future research, I'd like to focus on the reconfigurability of hardware security, and that is why I think that it is important to focus on these aspects of the research. So this is the end of my presentation. If you have any questions, you can contact me by email, or you can send me your questions. I will try to answer in my earliest convenience. Thank you for your attention.